About 7.9 million years ago, the largest inland body of water known in Earth's history entered a catastrophic decline. There was no asteroid impact, no supervolcano, no continent-splitting earthquake. And yet, on a geological timescale, its water level plunged by more than 820 feet. Vast stretches of lakebed were exposed. Shorelines retreated for hundreds of miles. One connected water world broke apart into isolated basins. This vanished giant was the Paratethys Sea, more accurately, the giant lake known as Paratethys. To understand its disappearance, we have to follow three clues: the rocks beneath it, the climate above it, and the moving continents around it. At its peak, Paratethys covered more than 1.1 million square miles. It was larger than the modern Mediterranean and roughly one-third the size of the contiguous United States. It held more than 425,000 cubic miles of water. If it still existed today, it would stretch from Eastern Europe deep into Central Asia. The Black Sea, the Caspian Sea, and huge areas of surrounding land were once part of the same system. But Paratethys was not one simple, shallow lake. It was a chain of enormous basins, linked by narrow waterways. Many of those connections were fragile. If the water level dropped even slightly, the channels could rise above the surface, cutting one basin off from another. The lake could fracture like a sheet of glass. Once a basin was isolated, its salinity, depth, and food supply could change independently from the water just beyond its shoreline. And that is exactly what happened. Geological evidence shows that between about 9.75 and 7.65 million years ago, Paratethys went through at least 4 major retreats. The final crisis was the most severe. Its water level fell by more than 820 feet. At the extreme, it lost roughly 70% of its surface area and about 1/3 of its total water volume. So where did the water go? The obvious explanation is evaporation. Maybe the sun simply baked the lake dry, or perhaps the crust split open and swallowed it. Another possibility is that a hidden outlet drained the lake toward the Mediterranean. But the rocks tell a more complicated story. Scientists reconstructed the event from sediments on Russia's Taman Peninsula. Deep water left fine clay on the bottom. Shallow water left carbonates and erosion surfaces. Dry periods even left sediments formed on land. Those rocks also recorded reversals in Earth's magnetic field. By matching them with the global geological timeline, researchers could date each major retreat. No single layer reveals the whole event, but stacked together, they preserve a step-by-step record of a water world repeatedly shrinking and returning. The sediment layers were the surveillance footage. The magnetic reversals were the time code. The most likely explanation is that Paratethys had become almost completely landlocked. Its remaining connections to the open ocean were shallow, unstable, and easy to block. Its survival depended on a delicate balance, rainfall and rivers coming in, evaporation taking water out. At the same time, tectonic forces were raising mountain systems around the basin and restricting narrow seaways. Then, during the late Miocene, large parts of Eurasia became cooler and drier. Rainfall patterns shifted. Rivers delivered less water. Evaporation kept going. Paratethys began losing more water than it received. Scientists still debate how much of the crisis came from tectonic isolation and how much came from climate. But the entire lake did not simply become one bowl of concentrated brine. As the water level dropped, the flat northern and eastern shorelines moved backward at astonishing speed. In some eastern regions, the coast retreated between 250 and 370 miles. In the north, it moved back roughly 60 to 220 miles. Different basins reacted in different ways. The deep central basin associated with the modern Black Sea received less fresh water. Salt became concentrated, and parts of it turned hypersaline. Some outer basins experienced the opposite. Rivers and rainfall diluted them, making them less salty, sometimes nearly fresh. The same crisis made one part of Paratethys saltier and another part fresher. This was not simply a lake drying out. It was the breakdown of an entire hydrological system. For the animals living there, the borders of their world were closing in. Millions of years of isolation had created species found nowhere else. Specialized mollusks, tiny crustaceans called ostracods, fish, seals, dolphins, and unusually small baleen whales. One of them, Cedotherium ryabenini, was only about 10 feet long. It looked more like an oversized dolphin than one of the giant baleen whales we know today. Scientists cannot simply say that salty water forced these whales to become small. Their size may have been linked to isolation, limited food, or the unusual ecology of Paratethys. What the fossils show is that this closed water world produced a highly distinctive community of marine mammals. Some whales, dolphins, and seals also evolved unusually dense, heavy bones. In highly salty water, buoyancy is stronger. Heavier bones may have worked like a diver's weight belt, helping the animals stay submerged. Different species arrived at similar solutions. Paratethys had become a natural evolutionary laboratory. Then the laboratory began to collapse. Habitats shrank, basins separated. Salinity swung in opposite directions. Food webs were disrupted. There is no evidence that thousands of miniature whales all died at once in a giant salt marsh. But the ecological damage was real. Endemic communities declined. Some microscopic organisms nearly disappeared. For life in the water, the retreat was a disaster. For animals on land, however, it may have opened a door. During the greatest retreat, as much as 675,000 square miles of former lake bed may have emerged. Mudflats became grassland, shrubland, and open woodland. A corridor of forest steppe stretched for nearly 2,000 miles across Eurasia. Regions once divided by water were suddenly connected by land. Mammals from Central Asia may have used these routes to move west into Europe. Predators, grazers, and smaller animals suddenly had access to landscapes that had been underwater for millions of years. The disappearance of a lake did not only destroy aquatic habitats, it may also have redirected life across an entire continent. But where did Paratethys come from? And what did it have to do with the legendary Tethys Ocean? This is where a common misconception needs to be corrected. Tethys was not one ocean that survived unchanged for hundreds of millions of years. Geologists distinguish between the Paleo-Tethys and the Neo-Tethys. They opened and closed at different times and in different places. Paratethys formed much later, around 34 million years ago, when northern parts of the broader Tethyan marine realm became isolated from the open ocean. So Paratethys was related to the Tethys system. But it was not simply a puddle left behind when the Paleo-Tethys died. To understand that deeper history, we have to travel back about 300 million years. The continents were assembling into Pangaea. Between major continental blocks lay the Paleo-Tethys Ocean. Later, fragments of land broke away from the northern edge of Gondwana and drifted north. As they moved, the oceanic crust of the Paleo-Tethys was pushed toward subduction zones. Oceanic crust is thinner and denser than continental crust. During a collision, it tends to sink. Some seafloor sediments were scraped off and piled against continents, where they were folded into mountain belts. Others descended with the oceanic plate into the mantle. Imagine a conveyor belt running for tens of millions of years, carrying an ocean floor into Earth's interior. But saying the ocean was swallowed does not mean every drop of water entered the mantle. Most seawater continued through Earth's water cycle, evaporating, falling as rain, freezing as snow, and flowing into other basins. Only some water trapped in crust and minerals traveled downward with the plate. What truly disappeared was the ocean basin itself. As the Paleo-Tethys closed, the Neo-Tethys opened farther south. Much later, Africa, Arabia, and India moved north. The oceanic crust of the Neo-Tethys was gradually subducted as well. Then India collided with Eurasia. Marine sediments were squeezed, folded, and lifted thousands of feet into the air. This is the tectonic story behind the Himalayas and the Tibetan Plateau, not the direct uplift of the Paleo-Tethys, but the closing of the Neo-Tethys and the collision between India and Eurasia. The vanished seafloor still left evidence behind. Along ancient collision zones, geologists find ophiolites, fragments of oceanic crust and upper mantle pushed onto land instead of being subducted. High in mountain limestone, they also find fossils of creatures that once lived in the sea. The ocean left no tombstone. It embedded its bones inside the mountains. And the story of Paratethys did not end with one great retreat. Around 7.65 million years ago, water expanded again and reflooded some basins. But tectonic collision continued. Landscapes kept rising, connections weakened. The giant lake fragmented again and again. Today, the Black Sea and the Caspian Sea are considered major remnants of that ancient water world. The basin that later held the Aral Sea also belonged to its vast eastern domain. So where did Paratethys go? Some of its water evaporated into the atmosphere and later fell elsewhere as rain or snow. Some remained in smaller basins. Parts of the old oceanic crust descended into Earth. Other pieces were compressed into mountains. The exposed lake bed became plains, grasslands, and migration routes. Paratethys did not vanish into nothing. It changed form. Its water entered the sky. Its sediments entered the land. Its crust entered the planet. And its outline still shapes Eurasia today. We tend to think of oceans, mountains, and continents as permanent. But on a planet measured in tens of millions of years, seas become mountains, lake beds become grasslands, continents cross the equator, and even the largest bodies of water disappear from the map. The only thing that lasts is change.